Hello friends, welcome back to our channel. So today we'll see one more concept in our computer networks, that too in TCP, which is a TCP congestion control. So in our previous session we have seen the TCP header and also whatever the services provided by the TCP to the upper layers. Now we'll see the congestion control, how the congestion can be controlled by the TCP. So let's start the session. So TCP congestion control. So already in our previous sessions we have discussed about this congestion, what exactly mean the congestion and how to control this congestion. So we have seen a lot of techniques. So quickly I'll recall this one. So congestion means having more number of packets over a network is called as a congestion, and simply we can say congestion is a traffic jam. So in the network the packets will be keep on moving, and if a lot of packets came into the network, immediately there will be a congestion, which is a traffic jam. So what is the impact of congestion? Once congestion occur, what happens? The first one, packet lost. There might be a chance of losing the packet. Okay, packet lost. Delay will be increased. A simple logic. So if we are traveling from one place to another, if there is no traffic, we will be reaching the destination within a time. If there is a heavy traffic, automatically there will be some delay to reach the destination. The same concept. And if the packet is lost, automatically the sender have to retransmit the data, I mean the lost packet. So there will be a lot of transmissions. So one more disadvantage is, already the network is overloaded, and these retransmitted lost packets will also be come to the network, or that may lead to more congestion. Okay, so this is the impact. Okay, and also slow internet. The result will be slow internet. So obviously efficiency will also be less. So in order to maintain or all these things, okay, the TCP will be using a process. TCP controls the congestion with a simple process. What happens? So the TCP will start sending packets slowly, because the TCP doesn't know how much traffic a network can hold. Okay, how much traffic a network can hold, the TCP doesn't know. So always the TCP starts sending the packets slowly. So if network is fine, TCP increases sending packets. First one. And if network is about to overload, what happens? The TCP decreases sending packets. Okay, right? So if we are traveling from one place to another place, if there is no traffic and roads are empty, automatically we will raise the speed. Okay, we'll increase the speed which we are traveling. And if the roads are having a somewhat traffic, automatically the will decrease the speed to reach the destination. So same concept here also, the TCP will be starting sending the packets first very slowly. If the network is fine, then automatically the TCP will be keep on increasing sending packets to the destination. And if the network is about to overload, automatically the TCP will be decreasing the sending packets. Okay, so for this particular congestion control mechanism, it will be using a term called CWND. CWND. So what it means congestion window. Congestion window. So we know this window. We have seen this window in a flow control, right? So window is a buffer. Imagine it is a buffer to accept the number of packets that can be sent to the destination without the acknowledgement. So we have studied in our earlier sessions. So for every packet we are sending, we'll be getting the acknowledgement. Then only we need to send the packet. So it will be a very time taking process. So that's why we are maintaining a window, so that the window specifies number of packets can be sent without acknowledgement. So without receiving the acknowledgement, the number of packets we can send to the destination. So this is a congestion window. The TCP will be maintaining this congestion window. So initially the congestion window will be small, and later, depends upon the network, the congestion window will be increased. So initially this CWND is less in size. So depends on network status, CWND will be increased or decreased. Anything can happen. If the network is about to overload, it will be decreased. If the network is fine, it will be increased. So the TCP will be maintaining this congestion control in 4 phases. 4 phases. So what are those phases? Four phases. What are those phases? The first phase, just now we have seen, that is a slow start. Slow start. So in this phase, CWND will be very less in size. Very less in size. For example, let it be CWND will be 1. 1 means only one packet can be sent. If we get the acknowledgement for that packet, okay, immediately the CWND will be increased. So after getting acknowledgement, then CWND will be 2 times. 2 times of CWND. Okay, double. So for example, let us take round 1 and CWND, the packets. First, only one packet will be sent. If we get the acknowledgement, okay, we get the acknowledgement. Next, the round 2, in the second round, 2 packets in the CWND, that means window size will be increased to 2. If we get a 2 acknowledgement for this, in the third round, this will become 4. If we got a 4 acknowledgements, then immediately in the fourth round we'll be getting 8. Okay, and in the fifth round, okay, it will be 16. So this is called exponential growth. This is called exponential growth. You can imagine this is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. It's an exponential growth. Okay, so this depends upon the network. Okay, if the network is about to overload, the CWND, that means congestion window, will be increased. So this is a slow start. This is a slow start. In the slow start, slightly the window size will be increased in an exponentially. Then second phase. Second phase. What is the second phase? congestion avoidance. Congestion avoidance. That means if the network is about to overload, okay, if network is about to overload, what we have to do? We have to reduce CWND, that means a congestion window. So previously we are increasing the CWND exponentially. Now also it will be increased, but the window size will be somewhat reduced. Okay, reduced and increased slowly, not exponentially. For example, here if round, it is round and this is a window size. What happens? First round 1, second round it will be 2, third round it will be 4, fourth round it will be 8, fifth round it will be 16. Now here we observe network is about to overload. Network is about to overload. What happens? Next, in the sixth round, the window size will be increased, but it will be increased to only 1. Seventh round it will be 18. So here you can observe the window size is increased with 1. Okay, so this kind of thing we call it as a linear growth. Linear growth. So always the window size will be increased, but coming to the, if the network is fine, the window size will be increased exponentially. But if the network is about to overload, not overloaded, is about to overload, then the increase of congestion window size will be linear. So one step. Okay, so this is the second phase. And the third phase, fast transmit, fast retransmit. So for example, if the client, and let it be, it's a server, okay, or you can simply we can call it as a sender, and it is a receiver. What happens? If sender wants to send 1 to the receiver will receive and it will give the acknowledgement of 2. That means I got 1, I am waiting for 2. Okay, that implies I got a 1 and I am waiting for 2. So in our previous session, connection establishment also, we have seen the sequence number will be added with 1, incremented, right? The same case. So if the second packet is sent, whenever the second packet is received at the receiver, it will send an acknowledgement asking for third packet. And if it is 3, it will be asking for fourth packet. Okay, so for example, 4, 5, 6, 7. So here the data is lost. The packet 4 is lost. Okay, packet 4 is lost. What happens? Again, the acknowledgement 4 will be sent, because at the receiver side it have to reorder everything. Right? So whenever it goes here, again it will be asking about 4 only. Again, whenever it goes, it asks for 4 only, right? It was asking about 4. That implies the packet 3 is received and I am waiting for packet 4. Packet 4 is not received. So whenever the retransmit will be done, so whenever the packet timeout, so every packet will be having some timestamp, right? So if the timestamp goes out, then immediately the sender will know that the packet has been lost and it will be retransmitted. So there will be a lot of waiting time. Okay, so it have to wait until the time is out. So instead of that, whenever it receives the acknowledgement 4, sorry, this is the process. Okay, acknowledgement means this one, acknowledgement 3, acknowledgement 4, and here it is again acknowledgement and again acknowledgement. Okay, hope you understood. One will received by the receiver, receiver will be sending the acknowledgement, right? So whenever this acknowledgement 4 received by the sender, okay, sender receives the 3 duplicate acknowledgement. These are called as a duplicate acknowledgement. So whenever the receiver, sorry, who will receive that duplicate acknowledgement? Sender. Whenever the sender receives 3 duplicate acknowledgements, then retransmission will be done. So what it implies means, if it receives 3 duplicate acknowledgements, that implies the packet has not been received by the receiver. So the packet has been lost. So if the packet is lost, immediately there will be a retransmission will be done. Okay, so without the packet 4, it can't be reordered that. Okay, receiver. So receiver will be keep on asking for the packet 4. So this is how the faster retransmit will be done. So it will not wait for the timeout. So it will wait for the 3 duplicate acknowledgements. Whenever it receives the 3 duplicate acknowledgements, immediately that packet will be retransmitted. And the fourth phase, fast recovery. So whenever there is a congestion, for example, if the network is congested, overloaded, that means congestion occur. What happens? Immediately the TCP reduces the window size and not start from the beginning. It will not start retransmit the packets from the beginning. Okay, so which packet has been lost, that packet will only be retransmitted. So that is a fast recovery. So whenever the network is overloaded, that means if the congestion occurs, immediately the TCP will be reducing the window size, and it will not start from the beginning. So it will retransmit the packet only which has been lost. Okay, so these are all the different phases involved in the congestion control. So by using all these phases, the TCP will be taking care about controlling the congestion over the network. Okay, so it will start slowly and it will be based upon the status of the network, it will increase or decrease the window size, right? So hope you understood this simple concept and important concept, and I'll stop here. And if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I'll try to clarify all your doubts. If you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.